You know, whenever I was walking up into this building from that way, I think it was that way, there's a couple gunshots off in the distance that didn't sound too far off. How much property do they own? Oh, how much property does the school have?
There's like a truck yard back there, like across the woods. Quite a bit.
I mean, I know it's Davie County. It didn't sound that far away. I was concerned about the safety and well-being of our students.
So math club's meeting this Friday? Okay. I won't be able to be there this week.
Why not?
I'm scheduled to go tour NC State.
On Friday?
That's where I'm trying to get into, and I didn't get to go on the sophomore field trip to see it.
Are you interested in being part of the competition team?
Yes. I feel pretty confident about the homework.
Yeah, it wasn't too bad.
It wasn't.
Unless I'm approaching it wrong, it's just a lot of plugging it into the calculator, right?
Well, some of it's like making the tables and stuff. But, yeah, for the most part.
Well, it still isn't making the tables, so you still plug this up in the calculator, just physically make the table.
Unless it's like 3 minus x, and you can probably do that mentally.
You'd have to check.
My only problem is what happens if you have the two equations and they have the same limit. How would you write that? Like the limit of what equation?
What do you mean they have the same limit? From the left and the right?
Yeah, but they're different equations on the left and right. How would you write that?
Like a piecewise function?
Yeah.
I mean, as long as they have the same limit from both directions, then the limit of f of x is that.
So you just put f of x, you put the equation in there? That makes sense. Huh?
Because f of x is equal to both parts.
Okay. That makes sense. For what? For which part, the worksheet or the?
No, not the worksheet.
The book, we were supposed to do number 1, number 21 through 51 odds, and number 63 through 73 odds. Oh, I only did that one.
And I told her, and it goes
Oh, I just
yeah.
Did you fill the graphs too?
Anything else?
It doesn't.
I know
forgot the graph, I just read it.
Or at least the graphs, I
I
don't
couldn't
know.
remember what he said in class, so I just went ahead and did it.
Is there a way that I can move up front? Because the one in the back you can't
Actually, Bree and Emily have both dropped.
I know they're beautiful, but I didn't want to write the whole
Everything
thing.
drop?
I'll just tell them at the beginning of class.
Okay.
Can you drop?
Wait, what?
Joe, are you there?
We're here.
Can I move over?
I just wanted to let you know that Brittany is moving up front so you can hear her better.
Can I move up front?
Fantastic. I was even going to suggest that it looked to me like there were enough seats on the front 2 rows for the entire back row to move up.
I think so.
Can I move up front?
Yep.
I'm going to say that's now a requirement.
I'm loud, I just can't hear.
I'm not loud.
I'm great at speaking.
You're also
hearing.
blind.
Yes, I am deaf and blind.
I've just learned.
So we already told you the electric bill.
Amanda,
I'm just stapling it.
Amanda,
Yes.
I don't know, our volume is very low. I'm gonna have to get her turn volume up, but, have you or anyone there looked at the videos that are on YouTube? It's cool. You looked at them?
Yes, Reza was talking about looking at the videos last week.
Okay, hang on a second, I'm gonna turn the fan down. I can barely hear you.
Okay.
Yeah.
Okay, so you said Reza was talking about looking at the videos last week?
Yes.
Okay. Well, the reason I ask is, I looked at one of them this weekend. My wife has never seen me. She said, I've never seen you teach. You teach for a quarter century, and I've never got a chance to see you teach. So here's my chance to see you. Because she didn't want to come in class and instruct me. So she could quote me a fly on the wall and look at the video. But to me, it was upsetting how poor quality it was. Is the experience you get live in terms of quality of video and sound from us? Is it similar to the recorded video? Well,
I'm not sure. I mean, sometimes the volume kind of goes in and out, but that's really the visual is really good.
Okay. That's because when I looked at the recorded stuff, the video kind of seemed fuzzy and jumpy, not just
Oh no, the video is like you're standing in front of us, but the sound it still has a little bit to be desired.
That was one thing that somebody was going to check on this. Well, how am I good?
Yes, we've got Jim making a recommendation about the brands, but we're still not sure if the PLI will create a competing commitment thing, the sound system.
Okay.
So that's something we're going to test. But honestly, the best way is, I think, to
That's the next year.
shut the doors and turn the fan off, because the soda machines outside, it's that under. We don't ignore it because we're human, okay? But the computers don't ignore it. So they pick up on that, and that makes the mics compete with that. Yeah.
So Sydney, if you wanted to move up one so that he can hear you, move up like one row. I think there's room for everybody now. Can you see everybody, Jeff?
Maybe.
Last row?
Well, no, we lost two. Front row, so there's nothing to see now. The entire back row is gone. So I have to rewrite my.
At least we're moving up to the front now. I think we're down to 12.
Oh, I can't. Isn't it that last scene?
So.
Well, I'm trying to fix it.
Right a little bit, or two. Left. So.
We've only covered chapter 1, we're doing chapter
How does that look? Can you see everyone?
Can you pan back, get a little bit wider angle?
Yeah.
Over the far left in the blue sweater, I can't see. I can't see Chloe now either.
Okay.
He said, I recommend these.
Put further back out, pan out a little more. Do you zoom back
One
a little more? Yeah.
Okay.
Maybe one more.
Michael Lee.
Oh, yeah, one more.
Can the front row move over one seat?
Well, no, they're gonna have this. Carson isn't there. Razor's not there.
Oh, okay.
So, okay, in the blue shirt, that was Elise. Is that Elise? Elise, raise your hand. Elise. Elise, are you there?
Yeah. She is on the front row corner.
That's what I thought, but then workers' comp.
Can you see him
So
now?
then, I can see about half of Elise.
Okay. But if I
Was that
move
the-
over, are you gonna miss Sammy?
Where is Sammy?
Okay, so that's Sammy.
Oh, that's Sammy. Okay.
Sammy and then Elise next to Sammy.
Now Elise next to Sammy then?
No, this is Brittany.
Brittany, I'm sorry. Where's Elise then?
It's the short hair. It's definitely the short hair.
Yeah, everyone confuses
Next
us.
to Brittany is Mason.
Yeah. Okay, so then one more time. Elise, where's it?
Over there.
So Sydney is,
Okay, we can't see Elise at all.
is Elise on the
Okay.
far right? So where Elise is?
So where should I put Kyle will be there? Is there anyone besides you, Chloe?
The problem was moving everyone.
So at least if you want to move beside Chloe, there's no one sitting there. You're fine there? Okay.
Is he still with us?
Sounds alright.
Bill and Josh, the next. Is that Sydney who moved up to
Yes.
second row with Kyle was? Okay.
Yes. And we'll put Kyle beside her and I don't know.
So,
As long as no one sits in that corner seat, we're good, right?
yeah.
So we'll take this chair away so Razor can't sit there.
Just go on clear with this.
Elise. Elise. Okay, I see Elise next to Mason, right? At Mason?
Yeah, I took
Razor.
the corner chair away so no one will sit there.
Okay. And Carson, Carson moved.
Move. Oh, move.
Okay, so Carson moved back next to Chloe.
Chloe, Carson, Dylan.
Kyle's gonna be there.
Chloe, Carson, Josh, Dylan, Kyle, and Susie.
That's it. Razor,
Reza, Elise,
Mason,
Mason.
Brittany, and Sam. Is that right?
Razor, you're still on the end there.
We're not allowed to sit there, is there?
No,
Yeah, I took a chair away.
I'm allowed to sit there.
Oh, wait, there's, oh, never mind, you can sit there.
Claire,
You're good.
I
Wake
think
up.
I've come to understand that it doesn't matter how quickly I leave or how efficiently I drive, the amount of traffic I'll encounter will always be proportional to the amount of time.
Light sits in this, I follow.
Yeah, I got in 10 minutes of traffic. It's awful.
Hey, it took us 30 minutes to get here.
It's always proportional. If I leave 5 minutes, like a 5-minute leeway, then I'll have 5 minutes of traffic. If I leave with a 10-minute leeway,
Light's here now.
yeah. But then I'll still get. Okay, I'll try back road next time.
Kyle's not here yet, is that right?
Correct.
Farmington Road just killed me.
Kyle doesn't have a reason.
I live on,
So you better
here's the thing, hey, I live
I'll try
on
back,
Farmington Road. The high school is literally 2 minutes away from
Can you see everyone now?
here.
Yes, I can see everyone.
Okay.
Sandy's still just about half in the picture, but
It's crazy.
maybe she leans to her right a little bit or something. Or you can you tilt to swing just a freckle to the left?
To the
Towards the
left.
wall? Or towards the wall, I guess.
Push to the wall.
Like toward Rezo or toward Sammy?
For Sandy, just like maybe a freckle.
To the wall.
A little more freckle. That's okay, there we go.
That-
Now we got it. Okay, that's good. Thank you.
So discontented.
Okay, so what questions do we want to discuss here?
always have to hurry. This is just a forecast of my life. I'll never be. I'll just leave an hour early.
Let's talk about the handout you worked on for homework first.
Oh yeah, Miss Cleaner, do you want this now?
Extra credit.
For extra credit.
So,
Ask him.
Okay. Ask him or Dale.
Dale.
Mr. Gaff.
number one, what did you determine for number one? Pardon me? Close to zero. Did everyone else get close to zero by getting close to 4 on the left side and on the right side? So if you did a similar type of process with a table, your answer should have gotten pretty close to 0 on either side of 0. What about number? Well, first of all, any questions on number one? Anybody have questions on number one? Put number 2 on the handout. As you got close to 4 from the left side and from the right side, what did you observe there?
Got close to 1 and 11.
You got close to on the left side. You got close to -1, didn't it? Or got close to -1 from the left side, right?
Yeah.
You got close to 11 from the right side. Everyone get that? -1 from the left, 11 from the right. So your answer might be something like this, where you want the center now, like this. Okay. So on number 2, you should have something like the limit x approaches 4 of f of x does not exist. And why does it not exist? Because the limit x approaches 4 from the left of f of x equals -1, which is not equal to 11, which equals the limit approaches 4 from the right of f of x. So we'll see other reasons that limits don't exist, but this is one reason a limit doesn't exist, is that the left side and the right side are not the same value. So we say that since the left side and the right side are not the same, then we say that the overall limit does not exist. We'll explain why it doesn't exist, and don't just put it does not exist. Okay? What about number 3? First of all, any questions on number 2? Everybody clear on what the answer is for number 2, and that you need to explain why it does not exist? Out of the dead zone. I was in the dead zone. Any questions on number 2? How about number 3? This one I don't know the answer to because this one's going to require approximations. Let's see, get close to it. How about Dave's? Okay, how about let's pick some home. Mason, what did you get for number 3?
Number 3, the limit of sin of x approaches roughly -0.757 as x approaches 4.
That sounds reasonable to me. -0.757 is the limit x approaches 4 of sine of x. I think that sounds reasonable. Anybody else get approximately that answer? I think it's, so I wouldn't, maybe not putting equals to, let's use approximately, because -4 technically is an irrational number, so you round it off to some decimal value. Okay, any questions on number 3 on that handout? Questions in general on that handout? Anybody? Davis County, are y'all good with the handout?
Sure. I'll take it.
Good. Okay, so now next up was homework in section 1.1. I asked you for homework to read it and to do at least number 1 of 1. I encourage you to go ahead and get started on the rest of it because it wouldn't hurt you, but at least we need to talk about number one, and then see what kind of questions and thoughts you have from your reading, and make sure we cover all that definitions and stuff clearly. So, I guess before we do number one, if you would use your book, and let's just kind of scan through all the definitions you were supposed to read, so that we're all on the same page. So we'll start. The section starts on page 78. There's no definitions there. Page 78 and 79 are kind of introductory, like what we did on Thursday, where we kind of set the stage of limits using kind of real-world example. But then on page 80, we start getting into just the kind of purely theoretical. We've got a bunch of definitions about limits, some of which we haven't discussed, including limit at infinity and then an infinite limit. Did y'all catch the difference between that terminology and what they mean by the definition on page 80? Limit at infinity is different than an infinite limit. But you can have both. You can have an infinite limit at infinity. So you see, the first definition on page 80 is what we've discussed a good bit Thursday. The rest of that is a little bit of an extension into the infinite world, but you need to be aware of those as well. Then we have on the bottom of page 80, the one-sided limits. I think we kind of talked about those some on Thursday. And then they take the opportunity to define what we mean by a vertical asymptote. You learned about vertical asymptotes in pre-calculus from the aspect of a domain issue. But now we're defining it in a calculus standpoint using limits. So a slightly different definition for a vertical asymptote involves if your x value gets close to a particular c value and your y value goes to either plus or minus infinity, then we call that a vertical asymptote. And horizontal on page 82 is defined just the opposite. If your y value gets close to a particular number L, when the x values go out to either end of the axis, plus or minus infinity, then we'll call that a horizontal asymptote. So slightly different definition for asymptotes than you probably saw in pre-calculus, but it ought to make sense also. And from a limit aspect, it really kind of makes it more precise than what you learned in pre-calculus. Okay, so that's kind of the quick overview of the definitions. So now let's get to problem one and see how we did with that. So volunteer to start us off with 1A like we've done in the past. Eddie, why don't you kick us off this one? Yeah, exactly. And in the definition, it has to have a value to exist. In fact, they also made the comment, if the limit number that you're going to, the output number, not the x value, but the output value, the f of x value, if that number is infinity, which isn't really a number, then we can say it doesn't. So it has to have a finite number that the y values get close to for it to exist. So that is true. I agree. How about 1B? Chloe, could you take 1B for us?
Sure. True or false? The limit of f of x as x approaches c is the value of f of c. And I got that was false because if you are like approaching infinity, like let's say c is equal to infinity, if it's like an infinite limit, I think, then you can't calculate the function if you input infinity.
That would be, yes, I agree. That's one good example of why that's false. Another example is, what I would suggest is, if there's a hole in the graph, you can have a limit that exists and still have a hole. Remember talking about holes in the pre-calculus section when if you cancel a factor in the numerator and the denominator, you end up with a hole in the graph? Well, that hole in the graph doesn't prevent the limit from existing, as the left side and the right side still will come together. It just has a hole in the graph. So that would be that the limit exists, but it's not equal to the function value at that point because there is no function value at that point. So there's a couple different ways of examining that. But yeah, certainly what Claude said about going out to infinity and then also getting close to a hole would be another example. Good. How about 1C? C. Sydney, would you take that, please?
I said, the limit of f of x as x goes to c might exist even if the value of f of c does not. I said that was true.
That is in fact true. We just described that just a moment ago. X values can get close to an open circle, and the limits come together, the sides come together, but there may not be anything at that open circle. So that, in fact, is true. How about D? Josh, would you take D for us?
True or false? The two-sided limit of f of x as x approaches c exists if and only if the left and right limits of f of x exist as x approaches c. I got false because the value of c can fluctuate in the given limit.
Well, it's false, but granted, c could be, anything. That's true. That's why we put a c there. It's not a specific value of c. But it's just a little bit of a small missing word, if you will. So if the limit exists from the left and from the right, so the limit x approaches, let's say, right here. Right, in this example we just wrote. So we see in this example that this limit exists. In fact, it's -1. And this limit exists. In fact, it's 11. But why does the overall limit not exist? What was the factor in there that made it not exist? Because they don't equal. So the statement is false because it requires not only that the left side exists and the right side exists, but it also requires equality here. There's like 3 parts to it. This part here is the part they don't mention in that statement. So they need to exist and be equal. And if they're equal, then they'll be overall limit will exist. How about E? Justin?
True or false? The graph that has a vertical axis that x is 5, and limit x is 5. I put E. False. I said you can go to infinity or negative.
That's correct. When the statement that they wrote infers, when you see on that statement, limit x goes to 5 of f of x equals infinity, that is inferring that, going back up here, the limit x goes to 5 from the left of f of x equals infinity, and the limit x goes to 5 from the right of f of x equals infinity. But that's not necessarily true. So when you come from the left, you could go to infinity, and from the right and go to infinity, and you have an asymptote. But you could come from the left and go to negative infinity, and the right to positive. But they both could go to negative infinity, and you would still have an asymptote. So it's false because it's too specific. It's not. It's too specific. Okay, how about now? Let's see. Brittany, could you take that for us, please?
true or false if the limit of f of x as x approaches 5 equals infinity, then the graph of f has a vertical asymptote at x equals 5? I said it was true because this is one of the situations that happen in definition 1.3.
Exactly correct. Yes, exactly. Exactly. Good. How about G? Kyle. Kyle, in the future, can you move up a row as well? You don't have to do it right this second, but just so we can see and hear you better.
Yes, sir.
Hey, Kyle, answer this one for us.
Alright, if the limit of f of x equals infinity as x approaches 2, then the graph of f has a horizontal asymptote at x equals 2. That's what I'm supposed to do? Yeah. I put false.
Next. Yeah, that doesn't make any sense, does it?
Correct.
I agree it's false, but why does it? To me, the whole statement just makes no sense whatsoever. I mean, how do you have a horizontal asymptote at x equals 2? I mean, at x equals 2, the best you can do is a vertical line at x equals 2. To have a horizontal, it's got to be y equals something. So the whole statement is just like messed up there. So yeah, that's absolutely false. And then what about H? Jacob?
True or false? Limit x approaches negative infinity at the graph of f has a horizontal asymptote at y. I said true. The limit x approaches infinity at f of x equals fail has a horizontal asymptote.
Exactly. It exactly matches the definition. Good. Good. Any questions on problem 1 out of the textbook? Anyone? From Davidson or ICC? Okay. Well, did you try any of the other homework? Let's ask that and see how we stand on it.
Yes, I did all of it.
Fantastic. Did you have any trouble with it?
I mean, the limits seem pretty simple.
Seemed pretty simple. I agree. Well, we're doing it numerically, so it's pretty intuitive, and I agree. And then generally, limits are not that hard, but we want you to really get a good concept. So we'll ramp up the heat over here a little bit too. Okay. Anybody else questions on section 1.1? Are we able to do? Like, I just want to make sure everyone's with us. Like I'm looking at page 88, and you're given a graph. You're supposed to. And then the first part, you're given some information. You're supposed to sketch a graph. Like, someone did the even numbers. Let's just ask you real quick to do on your paper number 26. Just on your note paper, real quick. Do number 26 on page 88. Just to make sure. I mean, hopefully everyone tried all the homework. Some people have already completed it. That's fantastic. Try 26, real quick. See what you come up with. Amanda?
Yes.
Is your smart tablet turned on or whatever?
Sure.
Sure.
Now.
I'm gonna have maybe one of ours do ours. So before we share, don't share anything yet. I'm gonna get one of ours to do it on our smart tablet, and then we'll get. Man, you can pick. You can be the mean person who picks who has to go up and draw it on your smart tablet. Okay.
Volunteers?
Well, whoever has the right answer should volunteer.
That's my thing.
Come on, Mason, you can do it.
What do you guys have last night? I'm gonna stand up. Here, this is my thing. This is probably
It's
wrong.
supposed to go down.
Oh, okay.
Because it approaches negative infinity.
Yeah, that's, I thought.
And then there's a reading dot.
I think that's right.
Right. So,
I just made
Wait
it
a
work.
second, that
Yeah.
passes one though.
volunteer to use this.
Did it pass one?
Two.
Then
I think it's.
I'll start you at what is on there. That's why for this.
Yes.
yeah.
Yeah, if someone wants to do that, go
You
ahead.
can just do it.
Or should I do it?
Come on, Raisin.
Okay, I'll do it.
You can do it. Do you want me to go ahead and share the screen?
Not yet. Go ahead and draw it, and then we'll kind of. I think we should share both at the same time.
I don't know, we've not done this before, but it's.
We didn't test this. We'll see in a minute. Who's the volunteer over here? I was looking down saying, it's not gonna be me.
Mm-hmm.
Have you got something you wanna please go on in for us? Let's try it.
I mean, you drew it kind of sloppy with us.
But this Rizzo's art style.
Wait, we're not going to get
I can mute the microphone and I can turn
So
the
whenever
camera
he's ready,
off. I have all the power.
you hit that.
Okay. Hello.
I mean, you could have made it a little bit straighter.
I'm sorry, it's kind of high. Okay, I'm not gonna make that joke. It's too early.
Way to make
What
thing you're
did you-
feeling comfortable.
I mean, you should be used to it by now, right?
Rizzo.
It's too early for this.
Yeah.
Be careful with these spots.
Is this
I really shouldn't. I should be asleep. I should be lost in like the void of the underworld or
He's hearing
something.
you, right?
Yeah, I know, but I'm waiting for Mr. Gaddis to tell me when he's ready. So I'm just waiting here with a button at my.
We're waiting for ours to be gone with no one compare. I don't wanna spoil the fun. You always gotta have the anticipation of unwrapping the gift.
Expected to socialize with Jesus.
Can I try to grab him? You put too much. Over too much. I'll just leave it there.
Yeah. Let's just. Please help.
Leave it there, please. I can draw a dragon here.
Okay, share, if you would, Amanda, share your screen with us real quickly.
This one?
Your tablet, your PC.
Oh, your pointy fingers. Okay, leave it alone.
The answer should get your simultaneous.
Can we not share ours?
Can you see it?
You can see it. It says I tried. It has a smiley face. Or actually, the circle seems to be covered by our boards. I can't tell if that's a smiley or a frowny face.
It's a frowny face.
Frowny face. Okay. I think that looks right to me. I would give the only suggestion I would make is to emphasize the asymptote aspect of it with the dash line. But other than that looks correct.
No, you can't read that one. Yeah.
Share ours
They
also.
need to stop sharing.
Okay, I guess, Amanda, apparently you have to stop sharing for us to share ours.
Okay.
This is why. I'm never gonna do this.
And this is what Joe did.
Oh, look.
Wow.
But they didn't have a face up there.
That was better.
No, it's not.
No, he didn't put a smiley face on his or a frowning face. And he included, although it was not required, notice there was a difference. Rizzo's graph did not have a horizontal asymptote, but his was correct. Joe's has a horizontal asymptote. Where is his horizontal asymptote?
On
Zero.
Right, 0 is correct. And that's also a correct answer. It doesn't preclude a horizontal asymptote up here, but he covered what was required. A vertical asymptote, and then a point that would normally be excluded. They wouldn't just magically put a dot in there so that there was a the domain now, the point is the domain is all real numbers for that function. Normally you would have a missing domain pointer too, but now there's domain is included of x equals 2. Okay, good. Questions on that one? Let's practice reading one real quick on the same page, number 30. About 34. So we got 4 things we have to decide: read and then decide an answer for from the graph. So someone want to volunteer to take number 34? We're not going to put this on the tablet. We're just going to read it and give you the answer. 34, the first one. Volunteer to read it and tell me the answer.
Just x approaches 0 is 2.
Heard that? Did y'all hear that at Davidson?
No.
No.
Nope.
Can you get louder, Joe?
The limit as x approaches 0 is f of 2.
Limit of f of x as x approaches 0 is 2. I agree with that. Okay? How about the second piece? Take a look at it for a minute. I'm going to ask someone else to do it. Number part 2. Sammy, can you take it?
I can. The limit of f of x as x approaches 1. It looked like it approached 1 to me.
I'm agree it looks pretty close to 1. Good. How about the third part? Dylan, can you take the third part?
Yes. The limit of x as it approaches negative infinity. No, as x approaches negative infinity, the limit of x is equal to negative 2.
I agree. Good. You take 34 part 4. Yes. Good. Okay, I think that seems all pretty straightforward. So what we'll do is start with a question. Did you? Oh, I'm sorry. Did y'all hear Maddie?
No.
Oh, okay. Did you hear what about it?
Limit of f of x at x approaches infinity is positive 2.
Good, thank you. That's exactly right. Okay. So what we're going to do is start on the next section of material, and I'm going to introduce that with a little handout as well. So, Ms. Taylor, if you could hand out the second part, I would appreciate it.
No, semi-formal, my favorite.
Semi-formal, yeah. You still don't have to put on a tux, but you do have to put on a sport coat. Okay. One comment, well, 2 comments. On the back side of this, I was looking at this morning. There's a typo on number 1. I think I need to hire a better secretary since I'm the one who types all this stuff. That should be -6.
Roast is gonna be geek.
Number 3, not a typo, but I decided it needs to be more exacting, and Can you, in rating mode, tell me what the sign of one is. 35, that's 1%. That's what I was thinking. So on number 3, if you would, add a little bit of accuracy to it, because in order to make it kind of behave the way we want it to, you need a little more accuracy in that example. Okay, so what we're going to do today is start by asking you, like yesterday or Thursday, to read the top half of the page and then get down to where it says explain why. There's like a right at the bottom third, it says explain why, blah, blah, blah. See if you can complete through that stage of the process, then we'll reconvene. This is a test we can discuss. Read it, try the first problem that it has you doing, and then we'll stop there. I would ask that you go ahead on your paper, right there next to the graph I've drawn, make a sketch of what you see when you do a zoom standard. Just sketch what the graph looks like in your viewing window. And then when you change it as required, make a sketch of the graph then as well. Right there on your paper, just make a little, just draw a little rectangle on your paper, represent your calculator viewing window. Sketch what you see in your viewing window. Has everyone gotten at least two graphs sketched and then try to write some kind of explanation? You know better on that? So I want to make a couple comments before we go over this. First comment is that we're working in a purely theoretical world called mathematics, and we're trying to deal with limits in a very theoretical way, but the concept has actual real-world applications. Besides being the foundation of calculus, it has real-world applications. For example, I was an engineer with Duracell batteries years ago, which, by the way, Davidson, was in Davidson County in Lexington. I lived over your way there 10 years ago. I worked at Duracell batteries, and we built machines that built the batteries. Well, the thing is, there's a certain specification, like this cell that has to be formed into a battery has to be a certain diameter, a certain length, within plus or minus. There's a little bit of allowance. It's not always perfect, but it's like maybe it has to be 1.1 inches plus or minus 0.001 inches. So there's a little bit of a tolerance, a specification tolerance on the build of a battery or almost anything. But in order to achieve that, the machine has to make that happen, or the human. So there has to be a certain amount of control on the machine. You have to be able to adjust the machine to get it within that spec. Or maybe if a part starts to wear out, as it wears out, then it gets sloppier in its build, and then the battery gets out of spec. So then you have to replace the part. Or maybe the part you specified initially just isn't really appropriate for the situation, and things are out of spec. So being able to control the input so that your output is in the right zone is actually very important. And that's what, in that aspect, this is, again, important information. So that was just a little background on it. So now let's talk about what did you see. So let's share the screen here. On your calculator, this is what you should have done. When you graph it with a standard viewing window, which is -10 to +10, if you just hit zoom standard, then you will get that picture. So my graph over here should look, I mean, you could have done this in pre-calculus fairly easily. You know it's got a y-intercept of 1, and it's a, so let's see. Oh, this is not looking that possible. Oh, you took off my screen. You needed to, thank you.
I mean, I can show you.
That's fine. I can look at it right here. It's got a slope of 2, so it's got to be pretty steep. Okay, so it's like maybe like this. Okay. Then you were asked, so I'm going to go back to this over here now. Then you were asked to go into your window setting and don't affect X at all, but go down to the Y and change it to a Y value of 5 minus, and notice I'm just typing in 5 minus, and I'm going to put 0.02, is that our given epsilon value?
Yes.
And then enter, and then I'm going to do on the Y max, I'm going to do 5 plus 0.02, so I don't even have to figure out what the number is. And then we'll graph again. That's what I see. Mm-hmm. So my picture now is, I see this, and then right next to it I see that. So what's up with that? I have an explanation that sounds reasonable why it would look so different? Sammy, thank you. What do you think?
I thought because you decrease the range quite a bit, but you still have the same domain.
Correct. Correct. Because this green line is still my axis, just like here. So when x is say 0, I'll cross the axis, but the axis where I cross is at y equals 1. Well, y equals 1 is not in this screen. And so I have x values here. For example, x equals 9. At x equals 9, the y value is up here somewhere. Well, on this screen, it's even further because this is a very narrow band of range values. As Sammy said, that's excellent. Okay. Question?
Amanda, can you push the monitor down a little bit on the instructor's desk? It's causing a weird wobble in our video feed.
Yeah, we'll pick that. It's true.
Every time the screen refreshes itself, it comes a wobble.
Amanda?
I'm not exactly sure what you're telling me to do.
There's a screen right there in front of you.
The monitor on the desk that you're at, can you physically lower the monitor?
Can you turn the turn the camera up?
Yeah, or turn the camera up will be good.
Turn the camera up just a little bit. It's showing up in the camera.
Yeah.
Keep going a little more. Right
Perfect.
there. That's good, right
Thank
there.
you.
Okay, so now the rest of the page on the front, you are to just guess and check to, well, it actually says now try a delta 0.1. So try that and follow the rest of the instructions. You're supposed to put in a delta 0.1 and see what happens. So let's do that. Delta, on my window, it says put in a delta 0.1. Delta goes with the x. You're controlling the inputs with delta in order to get within the tolerance of the y. So I'm going to go close to x equals 1. So 1, and the minimum is going to be subtract 0.1. And then the maximum, I'm going to get close to 1 on the other side. So I'm going to have 1 plus 0.1. So that's my x max. And then I'm going to graph again. So I just put in a small domain interval instead of a big domain interval to see what my graph looks like. And my graph looks like Vanessa?
I don't see it.
It'd be close to 1, didn't it? Or does it say be close to 2?
It used to be close.
That's my problem. Let's look back at my graph. I got nothing on my graph. Why might that be? Why might that be? Let's say you're on a test and you graph it like you do this same thing and you get like a blank. Like, my computer fouled up. Well, no, your computer did exactly what you told it to do. And I told it to do the wrong thing. So what did I tell it to do? Instead of zooming in at, this is supposed to be close to 2, I think is what we said. I zoomed in very close to 1. I missed everything. I'm right there between the y-axis and the actual graph. I missed everything because I messed up. It's not because my calculator is not working. I did it on purpose to show you all that. Okay, so window again, one more time. It's supposed to be what? 2 minus 2 plus.
Got him.
We get a better picture now. What happened there?
What did happen?
Now we got something that looks about like this. So this is 1.9, and this is 2.1 in the x dimension. This is 4.98 and 5.02 in the y dimension. And that's approximately what we see. Is that about what you get? So let me ask you a question. Again, thinking about building batteries. So I'm building batteries, and I'm trying to control the input so that the output is within spec.
Oh.
So there's something, so this is my spec, my tolerance, this is my control. So if something comes along and is right there as an input, is the output at that input value where my finger's pointing right there, is the output going to be within spec if that's my input? Looks like the output's up here somewhere. What about if I have that input right there? That's going to be, the output is going to be outside of spec. Are we seeing this? So my control is not tight enough to be within spec. So I'm making bad product. So I need to tighten my control some. Are y'all with me? So I got to get, like on the table, if you're at certain values, you're kind of starting to see a trend, but you're still not really there. We got to get tighter. So yeah, make it tighter. Now guess and check. The rest of it is on you. Guess and check until you find the biggest interval you can, find the biggest delta, how much you add and subtract, and to get everything in spec. What that's going to mean is, to get everything in spec, graph is going to look something like this, so that you're always between, no matter what input value, any input value in this window, if I have an input here, my output is within spec. If I have an input there, my output is still within the spec. So I need to know, this number we know is 2, and this distance is delta, and that distance is delta. You have to get some endpoints here, you have to try some different deltas. So I tried a 0.1, that wasn't really tight enough control. So find a delta control that gets you tight enough, and find the biggest one you can. I mean, if you went in and put 0.0000001, that's super tight control, and that'll get you there. But you know, we want the biggest we can. We don't want to have to spend $100 billion to make a machine that's that good control. We want to be able to spend the least amount of money and still make it happen. While you're doing it, I'm just going to emphasize what I was saying. If I put in a very tight control, like 0.00001, that's a super control. That's really super. How many zeros did I put in there? 4, 5 zeros. Wow. And then 2 plus 0.1, 2, 3, 4, 5, 1. And if I graph that, we'll see what the picture looks like. It's wrong. Something wrong.
Yeah, I think
oh, I didn't do a 1. I see. There we go. Keep forgetting that I'm at 2, not 1. So look at that picture shared on your screen. I put a super control in. I put 5 zeros and a 1 as my delta. What do you observe about the graph now? It looks like a flat line. I mean, we're making a line look different depending on what window we're looking at. I got a flat line almost. It's not really flat. It still has a slope of 2. It still has a slope of 2. It looks flat because of the domain and range I'm doing. But what it's saying to me is every value in that window, every input value in that window, will certainly be within spec. In fact, I could make my spec a lot tighter and still be within that window. You know what I'm saying? Because I got almost a flat line right down the middle. That's over control. I mean, that works. Yeah, that works. But that's over control. I don't want the best. To get the best, you got to find the biggest delta that still works. I found a very small delta that works. Find the biggest that works. That's what we do.
A pretty big one. Gives me a diagonal line. It's awesome.
Are you saying 0, 1? Yeah, it sounds to me like if you try, and I think this is what Joe just said, and others probably figured out, if you try delta equals 0.01, you should get this diagonal line that exactly fits in the window.
I mean, not exactly, but approximately.
Every X value in that window will have a Y value also in that window, which means I've got it controlled so that I'm within spec or within tolerance. Now, a couple comments about that, folks. First thing, we said the slope of this line, no matter what picture we're looking at, the slope of the line is always 2, correct? Because I haven't changed the functions. And do you see a slope of 2 on this picture now? I can actually see the slope of 2 now. Can you see the slope of 2 there? Okay. What's the total distance you see from there to there?
I can't even see what you're marking.
Can't see what I'm marking. Can you swing a little more to the left there?
Don't zoom in. Oh, okay, that works. I can dig it.
I can dig it. What's the total distance in the vertical tolerance that I'm talking about right there?
Is that 0.04?
0.04, good. And then what's the total horizontal distance I see right here? 2. And what's the slope of that?
0.04 over 0.02 is...
But I can actually see the slope there fairly easily as well.
I mean, it didn't look that way.
It looks like a 1-to-1 slope because it's going through the diagonal, but it's really 2-to-1 because of the window you're in. Okay. It's always 2-to-1. It's just a matter of how it's appears. My point to that is, well, my point to this is, choosing the delta and epsilon that goes with this epsilon. We gave you the epsilon of 0.02, and we had to pick a delta, and we found out that 0.01 worked. That worked nicely because this was a linear function. If the function is curving, that's not always the case. Let me emphasize that real quickly with the graph. So what if I have a curving graph? Depending on how you zoom in, you may lose some of your accuracy because of the curve. It won't be as simple as this, is what I'm trying to say. If I narrow my window down on this and try to zoom in, so let's say I'm zooming in right here. I'll magnify that for you. So let's suppose I zoom in and I pick the same type of window we had before. It may be that you don't get that same result. So on the left side, this is my C value in the middle. This is C minus delta. This is C plus delta. Vertically, this is my L value in the middle. Below is L minus epsilon, and above is L plus epsilon. So you've got this window, but what do you observe? On this window, the left side is definitely within spec. In fact, it's got a little bit of room to give. The X values on this side of C definitely map to Y values in my window. But what about the right-hand side? No, so my delta is too big here. You understand? I have to shrink my delta. So sometimes it's not going to be symmetric. Over here, a delta of 0.01 on the left and a delta of 0.01 on the right work beautifully. You can only have one delta. On this one, you might say, well, this side is 0.01 and that side's 0.01, but that's not gonna work. So I gotta shrink both sides the same, but that may mean one edge is gonna go through the side wall and one's gonna go through the top. You gotta shrink it so that both sides either go through the corners or go through the sides. Okay, so you gotta, ends have to
Ends league.
go through corners or sides, but not top, bottom. One more time. When you're doing this yourself, why is it that I just wrote that statement? I'll move this so the cameras can pick that up. Why is it that you cannot have one going out the top or bottom, but it's okay to go out the side? Ideally, you want it to go to the corners. I mean, that's ideal. If you can't get both corners, then get one corner and get the other one going through a side. So what I might do here on this one is I might get this top one going through the corner, so I might be able to shrink it down a little bit more. And I'm just, again, making up a picture here, but I might be able to shrink it down so that the right goes right out the corner there, but the left is still going out the side. So you may not be able, and so this is a new delta. This is smaller, so maybe this is, if I'm shrinking this, maybe this is 0.005 or something. That's half as big as this one. And so, I don't know, I mean, you just have to try. But the point is, in order to get everything within spec, you cannot have any place where the curve goes out the top or bottom. If you go out the top or bottom, then you now have an X value that doesn't map within the tolerance. If you go out the corners, that's ideal. At least get one corner, and if you have to, one of them going out the side. Now every X value in this window maps within the tolerance. Are we clear on that? So not everything is perfectly linear. In fact, most things in the world are not. So we have to be open to taking care of two sides of the coin. So your homework on this is the back side. You should summarize the top what we just did on the one example. You're identifying the maximum delta that works, and we said that was 0.01. And then write down the interval. We had that already over here somewhere. I think this was our interval over there. That was it. So you can write down your interval of X value. So we're saying that with that delta 0.01, then we can create a control interval of X values that guarantees all of the X values will land in the designated tolerance zone. And then I wrote a short paragraph after that. Let's read through that one. So that's just doing the graphical, looking at your graph and guessing and checking delta values. Finally, it says to argue that the answer is 5 because it works for any epsilon. And I think that's the idea. It's fairly easy to say that the definition requires us to be able to find the delta control value for any given epsilon tolerance value. In this function graph, there are no abrupt changes, and it behaves nicely in the nearby region so that, in general, when given any epsilon tolerance distance around L equals 5, we can determine a related delta control distance around X equals 2 that satisfies the definition.
That's good. Okay,
so there you go. You have 3 problems to work on that sheet, doing the same idea. I would suggest, again, that you make a sketch of your initial graph and then a sketch of your final graph that satisfies the definition, and then name your delta, your max delta that you got. Any questions on that? Okay. On each of the 3 problems, you're gonna make 2 graphs: a starting graph with a standard zoom, and then you're gonna do a graph that's the final graph that works with the given epsilon and the given. So you're using epsilon is 0.001 this time, and you got to find the maximum delta that makes it work. So you find a graph for that, and then state what is your delta that you're using in your graph, your max delta. That's all. So pretty simple assignment. Any questions on what to do with that? Okay.
So Dale, I have the rewrites of the
Oh, yeah.
test one.
Extra credit. Yes. Would you collect those?
Sure.
I'll collect one. What I want you to do here, hang on, I can tell my class this. I want you to staple your rewrite onto your original test, just so I got both. So I know that you.
What did he say?
Staple your rewrites to your original test.
Put the rewrite on top of the.
We got
the.
He wants the one with the grades.
Yeah, the one with the grades.
The one with the grades.
Have it?
I don't have my original test.
Oh, you don't have your original test.
Scan.
Well, if you don't have it, that's fine. Staple.
Give me the kids.
You just noticed we don't have it.
Yeah, he said it's fine.
I thought you liked it.
Yeah, man, I need to write darker.
That's why she interrupted me, because it's time. Okay, I guess one more time. So the rest of your homework, besides.
They're out.
They haven't left. They're just stapling their work.
Okay. I was just going to say, the rest of your homework is to read section 1.2. Problem 1. I haven't posted an assignment for 1.2 on Moodle yet. I'll work on that today as well. But read section 1.2 and do problem 1. Plus this sheet landscape. Yeah, you can get it. I'm going to trust that you get it.
Nobody says behind
People were
you.
taking that like.
I can tell what it is.
People were taking like 7 pages on here. Like I didn't even make it through 30.
Yeah, I only used
It took me like
Did you write the problem?
I even wrote the directions.
I didn't write the problem the first time.
I wrote a question I had.
I haven't highlighted that. So I'm
Part
gonna.
A.
I'm playing both things.
Have the note right here, or should I put it? I put this.
Amanda?
Alright, I'll send it to you.
Yes.
We need to do the homework
Do we
that.
have chemistry lab today or no?
Dale, did you have something to ask?
I was going to ask you, on this extra credit, Amanda, would you be willing to grade that for me?
Sure.
Are you around later? and call
There's
later or
one
something?
question that Chloe has, and I'll probably scan that question to you and let you handle that.
Yeah. Okay, yeah, she did that. That'd be great. When are you available to call?
Right after class would be good, if you're
Okay, so
available.
Are you going to have students or just to work with? Or
Does anybody stay
For what?
to ask questions?
No.
Okay. No, I'll be back in my office
I'll just give up on it.
at like 9:15.
Okay, I'll call you then. I'll see you in a little bit. I'll talk to you in a little bit.
Okay.
Bye.
I feel like rewatching my history project the last time.
I feel like this feels like.
I feel like it. We should let Miss Klinger watch it.
My hand one trying to get this like.
Oh, sweet, it's me. This is so much better than Chapter 0, Miss Klinger. Because I'm actually learning stuff and not just compressing a year's worth of material into 1 week, you know what I'm saying?
Not just for like.
Come on, go.
What are you gonna rush for?
This is on first homework. This is on bio. And then.
Do we have bio homework?
No, bio and study.
Was the bio, the chapter 3 questions under you, are they? Or did
I've
this-
done the learning star. I haven't done the science.
Those are all due the same day, right?
Dylan, you coming to Iowa?